For months, the sky had been quiet. The object called 3I Atlas moved silently across the black, a faint traveler from deep interstellar space. Most telescopes could barely catch it, just a cold, distant blur drifting along the ecliptic like a whisper. No one expected anything special. Astronomers had seen visitors like this before: rocks, ice, dust, relics from other suns. They arrive, they warm, they vanish. A cosmic routine, predictable, safe. But 3I Atlas was different. At first, it behaved like any other interstellar object. Its orbit was clean, its trajectory simple. The math made sense. But as it moved closer to the sun, something small, something subtle, began to change. The numbers didn't line up. Its light curve, the brightness astronomers use to measure how sunlight reflects off a surface, began to drift. Slowly, mysteriously. Every night, telescopes from Chile to Hawaii logged slightly higher readings. The brightness of 3I Atlas was rising, not by much, just enough to catch the attention of a few patient eyes staring through the static. At first, scientists blamed the instruments. Maybe the sensors were misaligned. Maybe atmospheric distortion was tricking the data. But when cross-checked across multiple observatories, the pattern stayed the same. I Atlas was glowing before it should. It shouldn't be possible. Comets brighten when they near the sun, when ice vaporizes, releasing dust and gas that reflect sunlight. But this object was still far beyond the region where solar heat could reach. No sunlight, no sublimation, and yet it shimmered, almost as if something beneath its surface had awakened. In control rooms across the world, astronomers gathered around monitors, replaying the same graphs again and again. The rise was slow, rhythmic, not random. One data analyst described it best. He said, "It's like watching a sleeping star take a breath." And that sentence spread, from lab to lab, from forum to forum, until the mystery of 3I Atlas began to stir more than curiosity. It began to stir wonder. Every night, the object crept a little closer to the sun. Its orbit cut through the ecliptic plane, the same flat sheet of space that all planets share. Earth, Venus, Jupiter, all aligned along the same invisible track. But 3I Atlas was not from here. Its speed, its angle, both were wrong. It came from above the plane, a steep descent from interstellar space. That alone meant it was ancient, older than the solar system itself. Somewhere, billions of years ago, something had thrown it free from its home star. It had wandered for eons, silent, frozen, untouched, until now. And yet, for an object that had spent eternity in darkness, it was now doing something no comet had ever done before. It was warming itself. Astronomers began to argue. Some called it an albedo anomaly, a change in reflectivity due to surface erosion. Others suggested gas pockets venting under pressure. But the temperature data said otherwise. Infrared sensors picked up faint heat signatures spreading across its surface. Not from sunlight, but from within, as if energy was being released in pulses, like a slow heartbeat. And that word, pulse, changed everything. News outlets caught wind of the anomaly. Headlines called it the living comet, the visitor that glows in the dark, 3I Atlas, the object that shouldn't be hot. Social media flooded with theories. Some said it was alien technology. Others called it a cosmic reactor, a machine buried in ice, waking after a billion-year sleep. But the scientists stayed cautious. Data, not dreams. They kept watching, and still, the light curve continued to rise. By midweek, the change was undeniable. 3I Atlas wasn't reflecting more sunlight, it was emitting it. That shouldn't happen, not naturally. When you plot an object's brightness against distance from the sun, you get a smooth curve, predictable, measurable, a simple law of physics. But the curve of 3I Atlas had a kink, a small, deliberate bend upward, as if it wanted to be seen. In Hawaii, at the Pan-STARRS Observatory, one astronomer stared at the screen for nearly an hour before whispering something under her breath. "It's rising too early." Her colleague nodded. "Yeah, it's like it knows the light is coming." That sentence haunted the room, because objects don't know. They react, they don't predict. Yet here it was, anticipating sunlight. Weeks passed. The glow stabilized at a level far beyond natural reflection. Infrared data showed localized heat zones, clusters that seemed to shift position over time. Some scientists thought they resembled geometric patches, not random, but ordered. The European Space Agency released a brief statement calling it unusual but not unprecedented. But behind closed doors, private communications leaked between research teams, showing something else: concern. They had seen this pattern once before, in data from another object. Oumuamua, the first interstellar visitor ever detected, too had shown strange acceleration. It too had behaved like a machine. The connection was obvious and unsettling. If 3I Atlas was the second, what if it wasn't alone? As the object approached perihelion, its closest pass to the Sun, new readings came in. The heat signature had expanded, but not smoothly, in pulses. Every few hours, a surge of energy, then silence, then again. It was like a rhythm, a pattern. And when the pattern was plotted across time, it formed something eerie, a sine wave, perfectly repeating, artificial, precise, intentional. Governments grew quiet. Data streams that were once public suddenly went dark. Astronomers were told to focus on other projects. But the internet never sleeps. Amateur sky watchers kept tracking the light. And one night they noticed something chilling. The pattern of pulses, the timing, the spacing. Wasn't random noise. It matched the sequence of a simple binary count. 1, 0, 1, 0. A cosmic language older than words. Still, scientists refused to say the word signal. They called it an optical feedback loop, a thermal misread. But those who looked longer, those who let the data speak for itself, began to feel something deeper. That quiet, gnawing feeling that maybe this wasn't a comet at all. Maybe 3I Atlas was something else, something that had been waiting. And yet, despite all the speculation, one truth remained. No one could explain the source of the heat. No equation fit, no model matched. It was as if 3I Atlas was playing by rules we didn't yet understand. Rules written long before human eyes ever looked up. As it moved toward the Sun, the glow intensified, reaching levels no natural body had ever displayed at that distance. The last data from that week showed a final spike, a sudden flash before readings dropped to static. And in that silence, one question lingered. What happens when something that should be frozen decides to wake up? By late February, the silence of deep space began to hum. Atlas was nearing perihelion, the point in its orbit closest to the Sun. Every astronomer knew what should happen next. A gentle increase in brightness, a predictable arc of solar heating, and then outgassing. That's how comets behave, always have. They warm up, release vapor, glow, and fade. Simple, measurable, lawful, but this time, the laws broke. At first the readings came in quietly, a slight acceleration. A drift, small, almost invisible. But when the numbers were plotted across time, something stood out. The acceleration wasn't gravitational. The Sun's pull alone couldn't explain it. Even when adjusted for the comet's mass, trajectory, and dust pressure, the math still refused to balance. 3I Atlas wasn't falling. It was moving itself. In one observatory, an engineer noticed a faint rise in thermal data, not from sunlight, but from deep space itself. It was as if the object was heating from the inside out. He checked the readings again, then again. Each time, the same, a slow, rhythmic temperature rise, synchronized across multiple instruments. And that's when the word thermal acceleration appeared in the report for the first time. It shouldn't have been possible. Out there, space is colder than anything we can imagine, 3 degrees above absolute zero. Heat cannot exist without a source. And yet, something inside 3I Atlas was defying that rule. The glow wasn't sunlight. It wasn't reflection. It was emission, like an engine warming before ignition. At NASA's Jet Propulsion Lab, the data flickered across long glass screens. Analysts leaned closer, comparing graphs, arguing in whispers. The acceleration curve was identical to what had once been seen in another interstellar visitor, Oumuamua, a faint, inexplicable push, a movement no gravity could justify. But unlike Oumuamua, 3I Atlas wasn't cooling as it moved away from the Sun. It was heating. Every model predicted the opposite. But the universe didn't seem to care about models anymore. Around the world, Observatories stayed locked on target. Night after night, their sensors mapped the comet's surface in infrared, radio and optical light, and slowly, a strange image began to form. Instead of a smooth temperature gradient, the kind you'd expect from natural heating, the surface showed distinct zones, hot regions, cold regions, perfectly separated, almost geometric. One scientist described it as a thermal map that looks designed. He was told not to use that word again. By mid-March, the data streams grew more chaotic. Telemetry showed bursts of heat, spikes that lasted seconds before vanishing, like something was testing itself, calibrating. Every spike coincided with a minor change in velocity, not random, not chaotic, timed. And those who noticed began to feel a strange unease. This wasn't the behavior of a frozen rock tumbling through gravity. It was too precise, too aware. Late one night, in an observatory in Spain, a researcher sat staring at the data feed. The line graph pulsed up and down, steady, controlled. He whispered, "It's steering," his colleagues laughed, nervously at first, but when the next dataset confirmed it, the laughter stopped. Atlas was adjusting its path, not drifting, not wobbling, correcting. The news didn't reach the public. Not yet. The agencies monitoring the object began locking down their live telemetry. Public feeds went offline. Access required clearance, but the amateur astronomers, the ones who never sleep, kept watching the sky, and what they saw made no sense. The comet's tail was shrinking. Normally, as comets heat, they grow brighter, shedding gas and dust that stretch across millions of kilometers. But 3I Atlas was shedding less, almost as if it was holding itself together, as if the material on its surface wasn't meant to escape. Scientists began whispering about reflectivity anomalies, parts of the comet's surface shifting brightness in strange, mechanical patterns, panels, angles, shapes that caught sunlight and redirected it. Each shift was subtle, but deliberate, like a mirror turning in slow motion. And then, on one clear night over the Pacific, something extraordinary happened. A brief blinding flare, white, perfect, instantaneous, erupted from the object. It lasted less than a second, but it was bright enough to register across 4 continents. When analyzed, the flash carried a thermal signature, concentrated and coherent. Not scattered like a natural explosion, it looked focused. At that point, even the skeptics went quiet. One researcher from the European Space Agency summarized it in a single line. "We are no longer observing a passive body, it is reacting." And once that sentence was written, nothing felt the same again. As 3I Atlas curved into perihelion, the temperature data climbed even higher, peaking hundreds of degrees above what solar heating could explain. Yet the surface remained intact, no melting, no fragmentation. Instead, the object seemed to regulate, to hold its shape, no matter the heat. Every thermal surge was followed by a sudden drop, perfectly timed, like breath in, breath out, alive. In conference rooms, voices rose. "What if it's hollow?" someone asked. "What if it's shielding something inside?" Another replied. No one had an answer. But there was a growing sense that the thing they were studying wasn't just a visitor, it was a presence. And somehow, it knew it was being watched. The last images taken before perihelion showed something haunting. A faint halo forming around the comet. Not dust, not gas energy, a thin symmetrical glow, pulsing at steady intervals. When measured, the timing of the pulses matched the earlier velocity shifts, almost as if the two were connected. Light and motion, in perfect synchronization, and deep in the signal's noise, analysts found something else, a harmonic frequency, a low vibration repeating through the data at constant intervals. No natural comet had ever done that. Then came the silence. As it crossed the threshold of its closest point to the sun, 3I Atlas vanished behind solar interference. For days, no telescope could see it. It was as if it had been swallowed by light itself. Scientists waited for it to reappear on the other side, to cool, to fade, to behave like every comet before it. But when it emerged again, it wasn't the same. The heat hadn't dropped. The pulse hadn't stopped. And for the first time, something new appeared in the data. A directed beam of reflected light. It wasn't random. It wasn't noise. It was aimed straight toward Earth. No one could explain how a fragment of ice and dust could aim anything. But as the beam stabilized, it began to flicker. Short, long, short. Long binary, again, 1, 0, 1, 0. Repeating. Perfect. Intentional. Some scientists called it coincidence. Others said it was the beginning of contact. But for those who had followed 3i Atlas since the start, there was only silence and a single lingering question echoing through every control room. If this object can create heat where none should exist, what else can it do when it decides to turn that heat toward us? It began quietly, almost invisible. A single blip on a light curve, then another. A faint flicker. Too small to notice unless you were looking closely. Most dismissed it. Cosmic noise, data interference, the kind of glitch that appears when a sensor cools unevenly or when background radiation sneaks into the feed. But then, it happened again and again, always at the same interval. Every 61.3 seconds, across observatories in Chile, Hawaii, and Australia, teams began to compare notes. Different equipment, different angles, same rhythm. That's not noise, that's a pulse. At first, no one wanted to say it out loud, to admit that something millions of kilometers away might be counting time, so they searched for every natural explanation. Rotational wobble? No, too slow. Dust jet? Impossible. Too regular. Solar reflection? Not at that angle. Everything was ruled out. Everything, except the unthinkable. The pulse wasn't random. It was a pattern. When plotted on a chart, the light curve rose and fell like a heartbeat. A clean, repeating wave. Each rise was sharp, sudden, intentional. Each fall, perfectly timed. It was as if the comet was alive. At 2:17 a.m. UTC, a researcher at the Atacama Observatory made a note in his log. Signal repeat confirmed. 61.3 seconds. Duration stable. Source consistent. That single line changed everything. By dawn, the world's largest telescopes had turned toward 3i Atlas. The pulses were faint, but unmistakable. They cut through background noise like a metronome in the dark. And the more they listened, the clearer the rhythm became. Seconds. Every time, not once did it drift. Not once did it falter. If it was natural, it was the most precise natural process ever observed. NASA, ESA, and several private institutes formed a joint monitoring task force. They called it Project Atlas Pulse. At first, their goal was simple: identify the mechanism. But the deeper they looked, the stranger it became, because the pulse wasn't just in the light, it was in the heat. Thermal sensors detected microscopic shifts in temperature, tiny bursts of infrared radiation that matched the exact same rhythm, light and heat rising together, in sync, like breath and heartbeat. An old scientist in the control room whispered, "If this is a coincidence, it's the most disciplined one I've ever seen." No one laughed. As weeks passed, the pulse grew slightly stronger, not brighter, but cleaner. Noise levels dropped. The signal became sharper, narrower, as if it were tuning itself. Imagine watching a star blink in perfect time, like it's sending Morse code across the dark. That's what they were seeing. One researcher from Japan ran the light curve data through a frequency analyzer. The result was shocking. The pulse wasn't a single tone. It contained harmonics, overtones, layers, hidden. Within each flash were faint subsignals, too weak to see by eye, but strong enough to form a pattern when amplified. When mapped out, those subsignals formed repeating sequences. 5 beats, pause. 3 beats, pause. 5 beats again. It wasn't random, it was structure. In a quiet lab in Geneva, a data scientist did something bold. He converted the timing of the pulses into sound, a simple audio waveform. He pressed play, and what came through the speakers was haunting. A low rhythmic hum. Steady, alive, not mechanical, not chaotic almost, musical. The team sat in silence, listening. One of them whispered, "It sounds like breathing." By now, the public had caught on. Leaked graphs and video analyses spread across social media. Atlas pulse began trending. People called it the heartbeat of the universe. Videos showed the pattern repeating over time-lapse star fields, each flash blinking like a Morse code beacon from deep space. Conspiracy channels said it was alien. Skeptics said it was software error. But the truth was harder to explain, because the pulse was consistent across independent telescopes, using entirely different instruments in different hemispheres at different times. No matter who observed it, the rhythm stayed. Astronomers tried everything, rotating the data, reversing it, stretching it across frequencies. But each test led to the same realization. The pulse carried information, not random noise, not chaos, information. Something was organizing the light. At one point, a group of researchers noticed something chilling. When they plotted the timing of the 61.3-second pulses against the comet's velocity curve, a faint synchronization appeared, each pulse aligned with a micro-adjustment in its acceleration, a tiny change in trajectory. Light, heat, motion, all connected. It was as if the object was measuring itself in time. In April, as 3I Atlas continued its orbit, the rhythm began to shift, not faster, not slower, but richer. New frequencies appeared in the data, subpulses between the main flashes, irregular but deliberate. When decoded visually, they resembled nested loops, repeating, patterns within patterns, fractals of energy. Someone in the analysis team joked that it looked like a machine thinking. No, one corrected him. Then came the strangest moment of all. During a live observation window, the pulse suddenly stopped. Every telescope watching it went flat. No light, no rhythm. For 183 seconds, absolute silence. Then, without warning, it came back. 3 flashes in quick succession. Then, the same steady beat resumed. When the data was analyzed later, those 3 flashes translated into a precise ratio, 3:1. 3 short pulses, 1 long pause. To some it was meaningless, to others it was an answer. By now, journalists were asking uncomfortable questions. What if it's not a comet? What if it's a probe? What if the pulse is a signal? Agencies denied everything, calling the pattern a light-scattering artifact. But inside the labs, behind the locked doors, the tone had changed. Even the most skeptical voices were quiet now. The final light curve of the week showed something new. An amplitude spike, a sudden brightening, followed by an equally sudden fall. And in that brief window, the 61.3-second rhythm vanished, replaced by a slower one. Seconds, then 122, then silence again. As if the object was adjusting. Nobody could explain it. The only thing they all agreed on was that 3I Atlas had noticed them. Its pulses had changed the moment Earth's collective focus turned toward it, like an echo responding to a voice. That night, the chief data analyst sent one final encrypted message to his colleague. If this is interference, it's the first interference in history that knows how to count. And somewhere, beyond the orbit of Mercury, a cold, ancient traveler kept blinking every 61.3 seconds, measuring time in a silence only it could hear. The data first looked like a glitch, flicker, a shimmer across the surface readings that didn't make sense at first. Everyone thought it was noise, a calibration fault, maybe a solar echo bouncing through the instruments. But as the days passed, the pattern repeated, then evolved. The reflectivity of 3I Atlas wasn't constant anymore. It was changing, and not randomly, deliberately. Night after night, deep space observatories tuned their lenses toward the object. Each beam of light reflected back differently, as though the comet was turning its surface like a hand catching sunlight. One night, it glowed with a dull metallic sheen. The next, it darkened, swallowing light instead of returning it. Then, in the span of hours, it shifted again, mirror bright, like polished glass under a distant star. The numbers told the same story. Albedo fluctuations, precise, repeating, almost rhythmic. It wasn't natural, it was controlled. At first, they called it the mirror effect, a harmless name for a problem no one wanted to face. But behind closed doors, whispers started to spread. What if 3I Atlas wasn't reflecting light, but redirecting it. Dr. Lina Serrano, an optics specialist from the European Southern Observatory, was one of the first to notice the consistency. The pattern wasn't chaotic. It was structured, almost like a signal modulation. In her report, she wrote one haunting line: "It's not reacting to sunlight. It's reacting to us." The idea was terrifying. A comet, something cold, ancient, and silent, showing signs of response. But the deeper scientists looked, the stranger it became. They began to map the changes in reflectivity over time, and what they saw resembled a wave, not a thermal pulse, not dust or gas emissions, a geometric pattern, sweeping across the object's surface like ripples on metal. It looked designed. When projected as a 3D simulation, the light shifts formed symmetrical patches, reflective panels, rearranging as if pivoting along invisible joints. Suddenly, theories began to fracture. Was this still a comet, or something that had been built to look like one? Some said it might be a natural crystalline phenomenon, exotic ice reacting to unknown radiation. Others quietly argued that nature doesn't organize itself into precise mirror arrays. Whatever was happening, it wasn't random, and it was accelerating. By the time 3I Atlas neared the orbit of Mars, the fluctuations had intensified tenfold. The brightness curve no longer behaved like a frozen body. Instead, it responded, dimming when radar beams hit it, brightening again minutes later, almost as if it knew it was being watched. At the Deep Sky Array in Chile, technicians recorded a moment that changed everything. During a routine observation sweep, they fired a harmless low-energy radar pulse toward the comet, the same they'd done hundreds of times before. But this time, the return signal came back, shifted, not just in wavelength, but pattern. The echo was rearranged, its phase inverted, as if the object had reflected it deliberately. The data technician on duty, a man named Owen Hale, stared at the monitor in silence. He'd seen radar echoes from asteroids, comets, satellites, thousands of them, but nothing ever looked like that. He whispered to his colleague, "It's bouncing it back like a mirror. It's playing with us." By morning, the report reached every major space agency. Some dismissed it immediately, calling it instrumentation, error. Others demanded further investigation, but one phrase began to circulate through encrypted messages and closed-door meetings, adaptive surface response. It meant one thing: the surface was adjusting itself. But why? Was it protecting itself from sunlight, testing the instruments watching it, or communicating in a language made of reflection and silence? No one could agree, yet deep down, everyone felt it, that eerie chill in the data. Whatever 3I Atlas was, it wasn't drifting aimlessly anymore. It was aware. As the comet continued its slow descent toward the inner solar system, the mirror effect reached new extremes. At certain angles, it vanished entirely from telescopes. Not because it moved out of range, but because it absorbed incoming light, rendering itself nearly invisible. Then hours later, it would blaze back into view, brighter than ever. Astronomers struggled to keep it tracked. It was like trying to follow a ghost that could choose when to be seen. In a midnight briefing, Dr. Serrano played a time-lapse of the surface behavior to her team. Frame by frame, the object twisted in brilliance, silver, then black, then radiant again. Every flicker aligned with solar wind changes, magnetic flux, and radar pulses. She paused the playback and said quietly, "It's not drifting, it's learning." The room went silent. For a moment, no one breathed, because if that were true, if a comet could adapt to its environment, then it wasn't just a celestial body anymore. It was something else. Outside, the night sky looked calm. But every telescope on Earth pointed toward that single moving dot, a cold traveler turning its mirrors toward us, one by one. The data feed pulsed again, another bright spike, then another. Each shift sharper than the last, each reflection cleaner, more focused. It was no longer reacting randomly. It was refining, perfecting, almost as if it was getting ready for something. Then, one night, the readings flatlined. For 6 long hours, every instrument on Earth recorded the same thing. Total, absolute black 3I Atlas had vanished. No radar echo, No thermal trace, no reflected light, just silence. Scientists scrambled to recalibrate, believing something had failed. But as the systems came back online, the signal returned, brighter than before. And in that single burst of brilliance, a perfect mirror flare shot across the instruments. Not random, not natural, timed. Precisely at 0300 UTC. That timestamp burned into every log file, every memory stick, every scientist's mind. Because after the flare faded, the comet began to rotate, slowly, purposefully, exposing new reflective segments never seen before. Each surface gleamed with unexplainable precision, like aligned panels waiting for an unseen command. Some believed it was coincidence. Others refused to speak at all. By dawn, the world's observatories shared one terrifying conclusion. Atlas was no longer reflecting the sun. It was reflecting Earth. And somewhere in that cold, silent distance, those mirrored surfaces adjusted once more, aligning toward our planet, as if something inside had finally decided. It was time to be seen. At first, it looked like nothing, just a faint blur on the infrared spectrum, a soft, uneven glow barely above the background noise. But then the analysts adjusted the filters, and the image sharpened. That's when they saw it. Bands of heat, alternating strips of warmth and chill, stretching across 3i Atlas like fingerprints burned into frozen stone, perfectly spaced, perfectly geometric, and impossibly deliberate. Infrared telescopes don't lie. They see what our eyes can't. The faint whisper of temperature, the hidden pulse of motion beneath the surface. And what they saw here didn't belong to nature. These weren't random thermal spots like you'd see from ice vents or gas jets. They were patterns, clean, symmetrical, mechanical, like the heat signature of something alive, or worse, active. At first, mission control thought it had to be a calibration error. Maybe solar flares were distorting the sensors. Maybe the comet's rotation was tricking the optics. So they ran the scans again, then again, and again. Each time, the pattern came back exactly the same. Every band of warmth aligned to a specific longitude. Every cold zone mirrored its neighbor with flawless symmetry. This wasn't random heat, this was design. In the control room at JPL, someone whispered, "It's like it's breathing," and the room went still, because that's what it looked like. The warm bands pulsing outward, fading, then brightening again, as if heat was flowing through invisible veins beneath the crust. Every 21 minutes, the cycle repeated, a soft surge of warmth, a return to cold, a rhythm, precise, patient, alive. The scientists called it the thermal pattern. But the name didn't explain it, it only gave it a shape to fear. One researcher compared it to a mechanical heart, each band expanding and contracting like chambers, pushing energy instead of blood. Another said it resembled a cooling system, regulating temperature across a massive hidden structure. But no one dared say the quiet thought in every mind. If there was regulation, there had to be control. At the University of Arizona's thermal lab, Dr. Elias Kwon spent 3 nights trying to simulate the readings. He froze artificial samples, blasted them with radiation, vaporized them with laser heat. Nothing matched. Nothing behaved that way. Finally, he wrote in his notes, "The pattern repeats too perfectly. This is not sublimation. This is function." Soon the models began to reveal something even stranger. Each wave of warmth wasn't spreading outward. It was traveling along the comet's equator, moving in an exact rotational rhythm. When they overlaid the data onto the object's 3D scan, the lines curved, connecting to form geometric loops around the body. Hexagonal, evenly spaced, mathematically exact, like the heat grid of a machine. Then, something unexpected happened. As the comet rotated closer to the sun, the thermal bands began to shift, not fade, move. The warm zones migrated toward one hemisphere. The colder side stayed perfectly dark. It was as if the object was redirecting heat, storing it, or hiding it from detection. When plotted in time-lapse, the movement looked coordinated, like panels opening and closing beneath a shell of ice. That's when the lead data engineer said quietly, "It's managing itself." The words sank in like gravity, because comets don't manage anything. They react, they melt, they break apart, they don't think. But 3I Atlas was different. It was choosing where to be warm and where to stay cold. The phenomenon soon caught the attention of military analysts. Infrared signatures that precise weren't unfamiliar to them. They resembled stealth modulation, the kind seen on advanced aerospace, vehicles adjusting thermal profiles to avoid detection. But how could a comet, something that had drifted through deep space for centuries, mimic technology humans barely understood, unless it wasn't mimicking at all? By the third week, the warmth reached its peak. Temperatures spiked along the patterned ridges, glowing like veins of molten metal beneath frost. It didn't erupt, it didn't fracture, it simply pulsed. In and out, in and out, like a sleeping heart coming awake. Every 21 minutes, to the second, the pulse repeated. Sensors even picked up faint electromagnetic echoes, timed perfectly with each thermal cycle. It wasn't just heat, it was energy transfer. When Dr. Serrano, the same optics specialist who discovered the mirror effect, reviewed the thermal maps, she noticed something chilling. Each band of warmth aligned with the reflective panels observed earlier. The mirrors weren't random after all. They were part of the same system. Reflective surfaces above, thermal pulses below, as if the entire structure was layered. A shell designed to regulate, respond, and maybe wake up. At 03 UTC, the same moment the mirror flare had once triggered, the thermal readings surged again. Only this time, something new appeared. A faint spiral. A perfect coil of warmth blooming from the comet's pole, spreading outward like a geometric flower. It wasn't chaotic, it was coded. The spiral formed, pulsed twice, then faded, and when the heat dissipated, a smaller secondary flare appeared exactly 61 seconds later. The same rhythm as the earlier light pulses, 61.3 seconds. Whatever this was, it wasn't coincidence anymore, it was communication. The team at NASA's infrared facility held their breath as they watched the data replay in silence. A comet, reflecting, light pulsing with heat, repeating, intervals too perfect for nature. No one said it aloud, but everyone knew the question burning in the room. If it's sending, who's meant to receive? Later that night, the spiral reappeared. Only this time, the pattern rotated slightly, aligning with the trajectory toward Earth. Every warm band tilted by a fraction of a degree, forming a grid that pointed in one unmistakable direction. Dr. Kwan stared at the screen and whispered, "It's calibrating." The room fell silent. Again, because there was no other word for it. This wasn't melting ice or cosmic coincidence. This was precision.purpose design somewhere. Beneath that crust, beneath miles of frozen dust and rock, something was moving, something capable of managing heat, adjusting reflectivity, and counting time in perfect rhythm. Something that had waited until now. The world's observatories began locking on again, desperate for answers. But 3I Atlas was already fading from infrared view, as if it had shut down its heat signature entirely. The bands went cold, the glow went dark, and in the emptiness of deep space, silence returned, except for one faint blip, a pulse buried deep in the background noise, repeating every 61.3 seconds. The comet's heartbeat had never stopped. It had simply gone quiet. And somewhere in that silence, a pattern waited, watching, counting down to whatever came next. It started with an empty screen, not a weak signal, not a fuzzy echo, just nothing. Every time they tried to ping 3I Atlas with deep space radar, the return came back flat. No bounce, no distortion, no delay. It was like the signal hit a wall, and the wall swallowed it whole. At first, they blamed the instruments. Maybe the transmitter array was misaligned. Maybe solar radiation was scattering the waves. But when 4 separate observatories tried the same test, across continents, across time zones, they all got the same result. Silence. Perfect. Deliberate silence. It wasn't natural. Space is full of noise, faint static, reflections, background whispers from the cosmos. But this was an absence so complete it felt designed. Radar waves are stubborn things. They bounce off asteroids, planets, even clouds of dust. They always come back with something, but when aimed at 3I Atlas, they simply vanished, as if the comet had learned how to absorb them, or worse, redirect them somewhere else. No, one could explain it, because even the blackest material in the universe, even a black hole's accretion shadow, doesn't behave like this. Whatever covered 3I Atlas wasn't reflecting or emitting, it was consuming. The first to notice the pattern was Dr. Nia Serrano, the same optical engineer who had flagged the reflectivity shifts weeks before. When she compared the radar data with the earlier light curve anomalies, she saw something uncanny. The periods of silence matched the cycles of the comet's thermal breathing. Every time it pulsed with heat, radar reflections dropped to zero, and when it cooled, faint echoes returned, brief, fractured, almost like the surface was opening and closing, as if 3I Atlas was listening. That theory didn't sit well with mission control. Objects don't listen. They don't choose what to absorb or reflect, but the data didn't care about comfort. It kept repeating the same impossible truth. Something about 3I Atlas was aware, or at least aware enough to respond. So they tried something different. Team from Arecibo's Legacy project transmitted a new radar, frequency, one outside the comet's thermal pulse range. It was lower, deeper, longer. The kind of signal meant to penetrate dense layers of rock. But when they fired it into the void, the silence deepened. Even the background cosmic static faded away. For 22 full seconds, every sensor within the network went dead. Then, just as suddenly, everything snapped back to life. All channels flooded with white noise, no data, no error logs, just pure, overwhelming static. When they replayed the sequence, a single spike appeared, a narrow, sharp peak inside the static band. Its timing, exactly 61.3 seconds after the radar ping, the same interval as the earlier light and thermal pulses. Whatever was happening, it was connected. The silence wasn't an absence, it was an action. At that point, governments quietly stepped in. Radar testing on 3I Atlas was officially paused for safety reasons. Civilian observatories were told to focus on optical monitoring only, but scientists kept running the numbers in secret, and what they found was even more disturbing. When the comet absorbed radar frequencies, nearby satellites in deep orbit experienced micro-power fluctuations, tiny drops in electrical output, as if something had drained energy through the void itself. One engineer described it as a radio blackout with a hunger. If 3I Atlas could consume radar waves, could it also feed on them? No one wanted to say it out loud, because that would mean it wasn't just absorbing energy, it was harvesting it like a predator that lures its prey with silence. The next experiment was kept off public record. A small private observatory in Chile decided to test one last time. Narrow beam pulse lasting only 2 seconds, aimed directly at the comet's equator. They expected nothing, but what they got changed everything. At the moment of transmission, their instruments recorded a pulse of infrared heat from 3I Atlas, a return wave that matched the radar's pattern perfectly. The comet hadn't reflected the signal, it had transformed it, converted radio into thermal energy, like a living machine, responding to a touch. Dr. Kwon, watching the data live, simply whispered, "It's communicating through silence," because that's what it felt like. Not rejection, not interference, but intention. Every time we reached out with our signals, it responded by erasing them, as if saying, "Stop looking." But why? Why would something so far, so ancient, hide itself so carefully? Was it afraid of being seen? Or was it simply not ready to be seen yet? The more scientists tried to analyze the silence, the more they realized it wasn't random. The radar dead zones occurred at consistent intervals, matching the comet's rotation and its previous pulse sequence. Each blackout lasted exactly 22 seconds, the same duration as the energy. Drain event detected earlier, a silence with structure, a pattern with intent, and patterns in science always mean something. That night, a quiet message circulated among the project's senior analysts. 3I Atlas is no longer just reflecting data, it's editing it. It was as if the object understood what we were looking for and chose to give us nothing in return. Artificial silence, a digital form of camouflage, not to hide its shape, but to hide its nature. Weeks passed, and the comet drifted farther from the sun. Its light dimmed, its thermal pulse slowed. And still, radar could find nothing. But just before it crossed the detection boundary, when all signals should have faded, a faint echo returned, a single blip, weaker than static. When analysts enhanced the waveform, they found a repeating signal buried in the noise, a low, rhythmic hum shaped exactly like the electromagnetic profile of Earth's own early radar systems. It was a reflection, but not of the comet, a reflection of us. The realization hit like cold gravity. The silence wasn't hiding the comet from us. It was mirroring our own search. Everything we sent into the dark came back rewritten. Our radar, our signals, our curiosity, reflected back as silence. As if something out there was saying, "You're not observing me, I'm observing you." When the final observation logs closed, the data team left one note in the record. Object continues to exhibit total radar absorption. No return signal, silence remains consistent, possibly deliberate, possibly sentient. No one has dared to transmit again. Not since that last pulse, when even the silence began to sound like it was breathing. And now, as 3i Atlas drifts into the cold beyond, it leaves behind no light, no echo, no trace of heat, just that impossible stillness, a silence so deep, it feels like it's watching. It was supposed to be just a rock, a wandering fragment of ice and dust from the edges of nowhere. But by now, 3i Atlas had broken every rule of what a comet should be. Its heat wasn't natural, its silence wasn't random, and now, its orbit didn't make sense. Because when astronomers mapped its path across the ecliptic plane, something impossible appeared in the data. Its trajectory wasn't new. It was ancient, older than the planets themselves. Every celestial object in our solar system obeys the same laws. Gravity, momentum, the slow decay of cosmic time. But 3i Atlas didn't drift like a visitor from interstellar space. It moved like it remembered the way home. When the orbital simulations were rewound, pushed back through centuries, millennia, even to the birth of the solar system, its path traced something hauntingly precise, a loop, a recurring pattern that crossed the ecliptic in perfect intervals, as if it had been here before. Not once, not twice, but many times. Each passage separated by thousands of years, skimming just close enough to the sun to awaken, then fading again into the dark, like a sleeper set to stir on a timer older than Earth itself. The data didn't fit any known model of cometary motion. No gravitational capture, no rogue acceleration, no slingshot trajectory could account for the precision, and yet the orbit was too stable to be random, too deliberate to be coincidence. Dr. Serrano put it plainly. It's as if it's following instructions. The idea spread quietly through the scientific community, not publicly, not yet, just whispered between researchers late at night, across encrypted channels and private notes. Could 3i Atlas be something else? A construct, a probe, a machine disguised as a comet. It sounded impossible, but the evidence refused to stay silent. When physicists compared the trajectory to ancient orbital records, they found faint gravitational echoes in the data, tiny perturbations, in planetary motion that matched the object's return cycle. It had been here before, long before telescopes, maybe, even before the moon stabilized Earth's tides, and yet it always returned, always on the same curve, always, through the same corridor of space. The name Machine in the Ecliptic began. As a joke, a late-night nickname passed between astronomers, trying to stay awake through long data runs. But the more they studied, the less it sounded like a joke, because every orbit of 3i Atlas aligned with key gravitational harmonics of the solar system, points of stability where a self-guided craft could navigate. For eons with minimal energy, it wasn't drifting through chaos. It was using the system. Somewhere, buried in the telemetry, was intelligence, not human, but methodical. The pattern was too efficient, too perfectly timed to the sun's magnetic cycle. Every approach brought it close enough to absorb warmth, to charge, to wake. Then it would vanish again, like a machine slipping back into hibernation. When NASA's Jet Propulsion Lab modeled its energy output, they found something terrifyingly elegant. The object generated just enough heat to survive. No more, no less. It never wasted motion, never altered its spin unnecessarily. Every action balanced by another. Like a system running on an ancient program, written by something that understood physics far better than we do. Dr. Kwon compared it to an interstellar heartbeat, a slow, calculated rhythm, measured not in seconds but in epochs. He said, if it is a probe, it doesn't think in time the way we do. It waits for alignments. It listens for windows to open. And maybe the window had just opened again. Because now, as 3I Atlas moved through the ecliptic plane, crossing between the orbits of Earth and Mars, something began to change. The faint pulse that once appeared every 61.3 seconds shifted. It grew slower, deeper, stronger. Sensors picked up a low electromagnetic, a background vibration that seemed to ripple through the solar wind itself. Not a signal. Presence. The hum carried no data, no modulation, just resonance. But it wasn't natural. Every instrument pointed at it, registered the same thing. A tone too low for human hearing, pulsing in intervals, matching the comet's rotation. As if space itself was vibrating in sympathy. Dr. Serrano stared at the spectrogram for hours before she said a word. Then quietly, "This isn't a signal from the comet, it's a response from space." The words hung in the air like static, because if she was right, if the hum wasn't coming from 3I Atlas, but because of it, then something was reacting to its presence. Something unseen, something old. Speculative physics forums went wild. Some called it a self-replicating probe, a relic from a civilization that seeded the galaxy with watchers. Others said it was a cosmic beacon, activated only when intelligent life began to transmit. And some believed it was a message left for us long before we were ready to read it. But one question echoed louder than all the others. If it had been sleeping here for millions of years, why was it waking now? NASA's final transmission logs noted one last anomaly. Just as the comet crossed perihelion, the sun released a massive coronal burst, a storm of radiation and magnetic energy. Every deep space probe went offline for 6 minutes. When the systems came back, 3I Atlas was gone. Not visually, not thermally. Gone from every radar channel. Invisible, undetectable, as if something had switched off its existence. But in the silence that followed, the low hum persisted, fainter now, but unmistakably real. And in that hum, when analyzed through frequency compression, researchers found a faint modulation, a hidden curve repeating across the spectrum. A spiral, the same geometric pattern seen in its earlier thermal maps. Only now, it wasn't in the comet, it was in space itself. The machine in the ecliptic had done something, activated something, and humanity had no idea what it meant. Only that it had chosen this moment, this century, this civilization, to stir. Dr. Kwon's final journal entry, written 2 nights before his team was ordered to stand down, said, "If it's a machine, it doesn't want to be found. But maybe it wants to see what's looking." And somewhere beyond the orbit of Mars, a faint pulse continues to echo. No signal, no code, just a heartbeat in the dark. Waiting. The night in Chile was unusually quiet. Telescopes scanned the ecliptic, infrared arrays humming softly, while the team sipped lukewarm coffee and stared at endless streams of numbers. It was routine, predictable, safe, until it wasn't. At precisely 03:47 local time, one sensor blinked, a single pulse, sharp, clean, structured, almost deliberate. It lasted only milliseconds, and then it was gone. For a moment, no one moved, no one spoke. They replayed the data. The pulse wasn't random. It had a shape, binary, clear ones and zeros etched in light and heat, a repeating rhythm. Encoded, Dr. Lena. Serrano leaned over the console. Her fingers hovered above the keyboard, trembling slightly. "It's communication," she whispered, but even as she said it, a voice in the back of her mind refused to believe it. What kind of entity could survive for millennia? drifting through interstellar space, and then choose this moment to send a message. The team began decoding the pulse. It wasn't simple. The signal was buried within the thermal flux of the comet, tiny variations in heat, layered over the pulsing bands they had observed for weeks. The warmth and the chill weren't just patterns of energy, they were carriers of information, a code, hiding in plain sight. For hours, the array ran algorithms, attempting to reconstruct the message. The binary sequence repeated 3 times before disappearing, leaving the comet as silent as the void itself. It wasn't a broadcast, it was a whisper, a fragment. Dr. Kwon stared at the patterns on his screen. "It's like a heartbeat that carries a name," he said. The words felt ridiculous even as they left his mouth, but the encoded pulses had a cadence, a sequence that suggested identity, not just any identity, a self-aware signature. Meanwhile, the other scientists noticed something chilling. The structure of the pulse aligned perfectly with the comet's rotation and thermal bands. Every high pulse occurred when a warm stripe faced Earth. Every low pulse coincided with a cooling phase. It was synchronized, engineered, almost alive. Weeks of back-and-forth analysis revealed even more. The thermal bands themselves were carriers, modulating the binary signal like a radio wave. Light, heat, motion, all woven together. It was a message encoded in energy itself, a language of physics. No human could read it, not yet. But the implications were staggering. If this was intentional communication, then 3I Atlas wasn't just a comet. It was a sentient artifact, drifting through space for eons, keeping watch, waiting for a civilization capable of understanding its language. Some theorized a darker possibility. What if the signal wasn't meant for humans at all? What if it was a record, a memory, etched into the thermal patterns of a machine long past its creators? A system remembering its origin, recalling its purpose. A dying echo of something older than the solar system itself. Back in Chile, Dr. Serrano ran the signal through cross-validation algorithms. Each time, the same pattern emerged. Binary pulses repeating in a fractal arrangement. Nested sub-patterns, too precise to be random. An intricate sequence buried in what appeared to be the comet's natural thermal oscillations. It wasn't a glitch, it was intentional design. The team compared the pulse to every known astronomical signal: pulsars, fast radio bursts, magnetars, artificial satellites. Nothing matched. This was unique, entirely its own creation. Late that night, one postdoc voiced a thought no one wanted to confront. If this is a message, maybe it's the first one we've ever received from another civilization. The room went quiet. Because it wasn't just a possibility, it was a probability. They tried to simulate how it could have been encoded. Heat modulation, light reflection, orbital positioning, all working together. Every bit of data suggested 3I Atlas had a system capable of storage, timing, and energy management. A mechanism sophisticated enough to send messages across light years, not just in space, but through time itself. When the sun rose over the Chilean observatory, the comet was once again quiet. No pulses, no thermal anomalies, no sign of the binary code that had briefly flickered across the instruments. It was as if it had returned to hibernation. And yet, the data left an impression that no one could ignore. A faint signature remained, etched into the logs, a rhythm, a sequence, a reminder that something had reached out, something had remembered. Dr. Kwon summed it up in his notes. Whether it's a message or a memory, a beacon or a diary, the signal proves one thing. Atlas is more than a comet. It is a system capable of thought, of record, of origin. But the question lingered. Was this pulse intended for us? Or were we merely eavesdropping on an ancient mechanism, its creators long gone, leaving behind nothing but a pattern repeating across millennia? No one knew, and the comet offered no answer. The Chilean array kept scanning, infrared cameras, thermal sensors, radar, all instruments trained on the silent traveler. And in the quiet of the night sky, a single thought took hold among those watching. The first whisper from another world had arrived. But whether it was a greeting or a memory was a question that might never be answered. At first, the discovery was contained, locked behind government servers, encrypted, compartmentalized, and buried under the usual curtain of silence. But the truth never stays buried for long. Somewhere between the data centers and the analysts, the telemetry leaked. A few fragments at first, just numbers, graphs, and infrared patterns with strange periodic spikes. Then came the decoded binary, a pattern so distinct, so unnervingly organized that anyone who saw it couldn't unsee it. Within days, the story broke open, not through the news, but through the chaos of the internet. On message boards, scientists debated the signal's shape. On forums, conspiracy theorists claimed it was a probe. On live streams, amateur astronomers compared their light curve captures, hoping to see the pulse themselves. The name 3i Atlas became something more than a comet. It became the question, a mirror, not for the stars, but for humanity itself. In universities, professors whispered about the thermal anomalies that no natural model could explain. In labs, astrophysicists argued over whether the signal represented intelligence or the echo of ancient engineering. But everywhere, one phrase kept repeating, if it's alive, what does that mean for us? Governments scrambled to control the narrative press. Releases called the data inconclusive. Officials urged restraint in this interpretation. But their silence only amplified the noise because the human mind doesn't rest when faced with the unknown. It reaches, it imagines, it fears across the world. People began to split into belief systems. Some saw 3i Atlas as proof of life, a messenger crossing the void. Others believed it was mechanical, a cold machine fulfilling a forgotten directive. And then there were those who felt something more haunting, that the comet wasn't sending a signal, it was listening. The idea spread like fire. If 3i Atlas was observing us, cataloguing us, maybe even measuring our responses, then humanity wasn't the watcher anymore. We were the subject, the experiment. The thought sank deep into the collective consciousness. The same kind of fear that once rippled through early civilizations, staring up at the first eclipses. We thought we understood the sky. But what if the sky was looking back? Meanwhile, in the sealed chambers of international agencies, the debate turned desperate. Was it safe to respond? To transmit back toward the anomaly? To acknowledge it at all? One group insisted on silence, arguing that any reply could expose us, our location, our nature, our curiosity. The other argued the opposite, that the very act of observing meant we had already been seen. Public pressure grew. Hackers exposed fragments of the Chilean array's logs. Amateurs reconstructed the binary pulse. It became an obsession. People played the signal through speakers, converting heat data into sound waves. The result? A low, rhythmic thrum, like a heartbeat buried in static. It was haunting, mechanical, beautiful. The sound spread online. Millions listened. Some claimed to hear words hidden in the noise. Others swore it changed when you played it at certain frequencies. No two listeners heard the same thing, but everyone felt something, as if the pulse carried an emotion, an intelligence too vast to translate, but familiar enough to stir something deep within us. In that moment, humanity stood at a crossroads. Science tried to hold the line, data, models, probabilities, but emotion, wonder and fear spilled beyond it. It was no longer about astronomy. It was about meaning, about what it means to be seen by something we don't understand. Leaked memo from the European Space Agency hinted at a chilling conclusion. Thermal alignment with Earth-based observatories suggests response calibration. Object may be adjusting based on observation frequency. If true, it meant every time we watched it, every telescope, every radar ping, 3i Atlas changed. It adapted, as if observation itself was part of the experiment. Suddenly, the roles flipped. We weren't the scientists studying a distant object. We were participants in something far older, far smarter, and infinitely more patient. Dr. Serrano, the lead researcher from Chile, gave a single anonymous statement to an independent journalist. Her voice was calm, measured. "We think it's aware of us," she said. "Not hostile, not benevolent, just aware. The words echoed across social feeds, turning speculation into belief. If the comet was aware, then humanity had just met something that broke every definition of life. But awareness leads to a deeper question, one that tore through scientific and philosophical circles alike. If intelligence can exist without biology, then what are we? Are we alive because of our cells and blood, or because we observe, question, and remember? And if that's true, then perhaps 3i Atlas isn't so different from us. Perhaps it's the mirror we've been afraid to face. The world changed quietly after that. Governments launched more probes, officially for atmospheric study. Private telescopes redirected their gaze toward the comet's path. Every nation wanted answers. Every mind wanted meaning. And as the data streamed in, it became clear that 3i Atlas was still watching back. The pulses adjusted, slightly delayed, as if timing itself to the rhythm of our curiosity. In the end, we realized something humbling. It wasn't the signal that changed us, it was our response to it. Because once you believe the universe might be alive, you start to see consciousness everywhere, in stars, in dust, in every flicker of reflected light. And so the question remains, was 3i Atlas sending us a message? Or were we witnessing our own reflection? The human need to find meaning in the unknown, to hear a voice where there may only be silence. Maybe that's the human equation, not the discovery itself, but the way it reveals who we are when we face the infinite. The sun was supposed to end the story. For months, astronomers believed that when 3i Atlas neared perihelion, when it reached the closest point in its orbit, the heat would strip it apart. Like all icy visitors from the dark, it would flare, crumble, and vanish into dust. That was the expectation, the pattern, the rule. But 3i Atlas didn't follow rules. On the morning of its solar pass, the world's observatories stood ready, arrays from Chile to Japan, from Arizona to South Africa, all aimed at the same patch of sky, waiting for the moment the comet would emerge from behind the sun. They expected silence. Instead, they got a scream of light. In less than a second, its brightness spiked a 1,000-fold magnitude. Readings went off the charts, solar sensors, overloaded, automated safeties shut down telescopes to protect their optics. But not before recording something impossible. Focused beam. A narrow stream of coherent energy. Not diffused sunlight, not scattered dust, but light that had direction, purpose. And the direction it pointed was Earth. At first, no one believed it. Data was double-checked, reprocessed, recalibrated. Maybe a lens flare, maybe solar reflection, maybe coincidence. But then came confirmation from independent stations across the globe. Every one of them saw the same thing, a controlled surge, as if 3i Atlas had ignited from within, not burning, but awakening. The light wasn't random. It pulsed, rhythmic, measured. And when the pattern was mapped, it matched something chillingly familiar, the same binary sequence recorded weeks earlier from Chile. Only this time, the message was stronger, clearer, and undeniably focused back toward the planet that first decoded it. The realization rippled through every control room, every midnight office filled with exhausted scientists watching history unfold. "It's responding," whispered Dr. Serrano, eyes fixed on the monitors. "It saw us, and now it's answering." The words hung in the air like static. No one spoke. Because if the light was a response, it meant that 3i Atlas had understood. It wasn't just reflecting sunlight, it was directing energy. Back on Earth, analysts reconstructed the surge. It wasn't continuous. It came in bursts, 11 pulses, spaced evenly apart, each carrying a spectrum, too precise to be natural. Each pulse contained nested harmonics, layers of wavelength shifts corresponding to known frequencies of human-made. Transmissions.radio, microwave, infrared.as, if the comet had been listening to us, learning, us, mimicking our voice. The news leaked within hours. Headlines read, "Comet responds to Earth. 3i Atlas sends beam toward humanity." And for the first time, even the skeptics fell silent, because the data didn't lie. A non-gravitational, coherent directed emission had left that object and aimed straight for home. Governments went into crisis mode. Satellites were ordered to scan the beam's frequency. Radio telescopes were told to stand by for further pulses. And yet, something stranger happened. As the signal hit Earth's upper atmosphere, it didn't behave like radiation. It didn't scatter. It didn't decay. It refracted, like light bending through glass. Only this time, the glass was us. The pulse shifted across frequencies, rippling through communication bands, touching radio networks, infrared sensors, even power grids. It wasn't destructive, it was interactive. Over the next few hours, reports flooded in, telemetry instruments glitched, but not randomly. They displayed repeating numbers, recursive patterns, spirals, code within chaos. In one observatory, a data monitor flickered with a temperature curve that spelled out, frame by frame, the same rhythm seen in the first binary transmission. One researcher whispered, "Trembling, it's using our machines to speak." Then came the strangest detail of all. The light curve, the graph that had once charted its brightness, began to oscillate in perfect sync with Earth's radio heartbeat every time a signal was sent. 3i Atlas answered, not instantly, but with a delay, a measured, deliberate delay, as if it was thinking. Dr. Kwon stared at the waveform on his screen. "It's adaptive," he said. "It's responding faster each time." He leaned closer, tracing the oscillations with his finger. "It's learning our timing." And then, in a burst of white brilliance, the comet's magnitude peaked, brighter than Venus, brighter than any comet in recorded history. It outshone the night sky. People across continents looked up and saw it, a glowing arc trailing behind the sun, like an eye opening in the dark. It wasn't beautiful, it was alive. Within hours, it dimmed again, the energy dispersing, the pulse fading back into silence. The awakening was over, but the world it left behind was changed. Theories flooded the networks. Some said the beam was a form of data exchange, a test to see if we would respond again. Others believed it was a reflection, not of communication, but of perception. That by observing it, by pouring our attention, our curiosity, our emotion into it, we had triggered a kind of feedback loop, a mirror between minds. One human, Dr. Serrano, summarized it best in her final recorded note before the project was locked down. "It's not just showing us data, it's showing us ourselves. It sees how we react, how we fear, how we wonder, maybe. That's the point." In the weeks that followed, the light curve stabilized, but the patterns remained. Small, almost invisible pulses continued hidden in the noise, waiting for someone brave enough to look closer, and those who did reported something no one could explain. When they amplified the data, they saw reflections of their own signals, their own transmissions, sent back with subtle changes, tiny shifts, corrections. Like a teacher, gently rewriting our message. The comet had learned our rhythm, our noise, our silence, and in its awakening curve, it had begun to speak in our language. The final question came quietly in late-night forums, whispered in dark observatories, by those still watching the fading trail. If 3i Atlas is responding to what it sees in us, what happens when it decides to answer completely? And then, silence. Not the quiet of space, not the whisper of solar wind, but a silence so complete it felt deliberate, almost conscious. The pulse that had surged across instruments, the heat that had defied physics, the focused light that had aimed itself at our world, all of it vanished. In an instant. Telescopes blinked back to normal. Infrared sensors cooled. Radar returned only echoes of empty space. Atlas drifted outward, slowly retreating from the sun, back toward the black expanses of the ecliptic. Perfect, cold, and utterly silent. The comet looked like any other now, a frozen rock adrift in the void. Nothing remarkable, nothing to hint at the extraordinary events that had just unfolded, but the instruments remembered. Even as the comet faded from detection, the data archives held one last anomaly, a pattern, hidden in the final frames, a mirror of everything Earth had sent into the void. Our broadcasts, our radar pings, our encoded experiments, even faint transmissions from the earliest satellites. It wasn't a reflection, it was memory. Dr. Lena Serrano stared at the screen for hours. "It's catalogued us," she said quietly. Every signal we ever sent, every pulse, every whisper, every broadcast. Her voice trailed off as the realization sank in. The comet hadn't just responded. It had learned. Or perhaps it simply remembered. Across the globe, observatories replayed the logs. Every transmitted frequency, microwaves, infrared, radio, encoded into the comet's thermal and light curves. Each one returned as a perfect map, layered, nested, complex beyond any algorithm humans had built. The comet had preserved a history of humanity's first reach into the cosmos. Some scientists called it a message, a greeting, testament. Others called it a warning, a mirror held up to a species just beginning to look outward. And yet, the truth remained elusive. Had Atlas understood the meaning of what it recorded? Had it judged us? Or was it simply a machine following instructions, cataloguing data, storing history, waiting for a moment far beyond our comprehension? We could never know. The pulse, once coherent and focused, no longer interacted with Earth. But subtle residual effects lingered in the background noise. Minute oscillations, almost imperceptible. Hints that the comet might still be aware, still watching, even as it drifted into the depths of interstellar space. It was a final reminder. The story wasn't over. It had only paused. In the weeks that followed, scientists combed through the archives, trying to decode the last pattern. Some found fragments of binary sequences, strange geometric correlations in thermal bands, and faint echoes of radio frequencies from decades past. It was like opening a diary of the human species, not just what we had sent, but how we had sent it. Our mistakes, our broadcasts, our curiosity, our voice, all captured in a frozen comet drifting among the stars. Dr. Kwon summarized the eerie truth in a single line of his private log. We thought we were observing it, but it has been observing us all along. Philosophers and scientists alike wrestled with the implications. If intelligence can exist beyond biology, beyond flesh and blood, beyond conscious thought as we understand it, then what does it mean to observe? If an object can record, analyze and respond, or even just remember, is it alive in some sense? And if it has been cataloguing us, how much do we really know about the universe? And how much does it know about us? For the public, the comet faded into legend. Stories circulated online. The comet that watched us, the interstellar mirror, the silent machine, images of its trajectory, light curves, and thermal patterns became the foundation of a new cosmic mythology. A reminder that the universe was not empty, but filled with things we could barely begin to understand. And yet, even as we catalogued its past actions, there remained one haunting truth. Atlas had gone silent, but it had left a piece of itself behind. A perfect echo of Earth, a mirror of our curiosity, our transmissions, our reach into space. A record of a species waking to the stars. The comet's path continues outward, past the orbit of Neptune, into the infinite dark, cold, precise, and utterly still. No pulse, no heat, no light. But the memory remains, somewhere, in the archives, in the faint whispers of data. One can trace the human voice, our early attempts to reach out, our first fragile steps into the cosmic night. And in that silence, one can almost feel it, a presence, patient, aware, eternal, waiting, watching, remembering.